Okay, good day to everyone. Um, Today we're going to begin a new topic for the channel, and that would be called sequences and series. Okay, so basically, the first question is what's a sequence? What's a series? Okay, so uh, I guess a simple way to kind of describe this would be a pattern. Okay, so you see a pattern somewhere and you're able to quantify it, say with numbers. Well, it could be a pattern, say January, February, March, April, May, June, etc. But um, I'm going to kind of stick to numbers in this. That would be a pattern, I guess. Uh, so if you can put it into some numerical form, then we're going to probably deal with that on this channel. So in this pattern, it's similar to when you have X and Y, but in terms of sequences in series, we're going to start to see this other variable N, and then you're going to see the other Y value can be represented as A of N. It could be also B of N or any other subscript N. So you could see this, you could see B of N, it's all, or C of N. It's a bunch of different ways that they represent the Y value, but it's still kind of a function in a way. But let me be very clear. N does not take on any other values except positive integers. So that's a big difference. You're not going to see decimals or no decimals, no fractions here for N. It's only positive integers, and I believe they're called the natural numbers. Okay, the natural numbers meaning +1, +2, +3, dot dot dot, etc. Okay, so that's what N values take on. So the Y can take on any form. Okay, traditionally, whatever you saw in the past, for instance, I could have something where in the past it was Y equals 1 over X. Okay, but now what you're going to see is something a little different. You're going to see a function of N here is 1 over N. Okay, and then if you want to be even more specific, you could say this A to the N equals 1 over N. Okay, so that's the way this is going to work. And when you plot this, meaning where you have natural numbers and you have integers, only positive integers, okay, for values of N, when you do a plot of this, you're going to get your A of N, say your sequence in general form would be this. This would be a general form here. Okay. And I can get any number of the values by just dumping in whatever N I want. So for instance, if I'm dealing with this one here, what would it look like? Well, here's your N. Okay. Here's your N and here's your A of N. All right. So what would it be? Well, it doesn't start at 0. It starts at 1. So I'd have 1 over 1, okay, because this is 1 over N, right? And then that would be 1. Number 2, 1 over 2, 1/2, okay? So you get it, right? So it's like 3, 1/3, and then finally maybe 4, 1/4, okay? So when I plot this guy, I'm going to have 1, 2, 3, 4, okay, and N goes on the what typically is your x-axis is N, and A of N would be your y-axis, okay, and it would be plus and minus. It goes down to minus, but the N is always going to be plus, okay. So Now I have 1, 1. So if this was 1, 1, that would be 1/2, 1/4. Okay. 1/3 rather, 1/4. So here's 1, 2, 3, 4. So these points represent the graph of this sequence. Okay. So at this moment, I'm calling this a sequence. So what would that sequence look like? Okay. So in this case, the sequence would look like this, separated by commas. 1, 1/2, 1/3, 1/4. Okay, and that would be at what? N equals 1, 2, 3, 4. See? So here's your sequence, and it's separated by commas. So this here is a sequence. Now, when it becomes a series, we have a little bit of a change in the way we look at this data. So then you have n is 1, 2, 3, 4, no change there. But the series is when you add up the sequence. So it will be 1 plus 1/2 plus 1/3 plus 1/4. So in this case, if I went from n equals 1 to n equals 4 in this sequence here of a to the n over n, okay, then I would get this number. I would get 1, 1/2, 1/3, 1/4. Okay, so you'd have to actually put this together somehow and summate it. Okay, and you would get a value. So so what would I? How would this work? Okay, so I'm getting. Oh, one more thing here I have to point out. These guys, whether here or here, okay, are all called terms. They're terms or elements. Okay, so you have a choice. I think the most popular word is terms. So these are terms also or elements. Okay, now if you wanted to declare what element are you looking at, well, this would be the element at A1. Okay, so A at N, this means this is A at N equals 1. You see? Now this one here would be your A3 element, okay, or your term. And that's when N equals 3 of this general form of a function here. Now, I liken these graphs to what comes to mind is a scatter plot. Okay, for instance, they're points, a set of points. Okay, they're not going to give you a line. There's no value of y or no value of x between these integers, so you have no data on that. You're just dealing with the whole number, the natural numbers here, and you're getting points along the way. So in general, that's what's going on here. Now, when I have this formula a to the n, 1 over n, they call that the general term, okay, or the general formula, because now I can simply get the general formula to kick out any n I would like. So if I ever desired to have the 100th term, I would set the n equal to 100, and I'd have 1 over 100. And there you go. Right away, I can kick out any term in this series right up to the nth term. That would be the nth term would be the last term, okay, the last term in this. Sometimes we cut it off and we only go for so many terms, in which case there would be, we're going to get into that soon, and you would see some other ways that they would show you how many terms there are. okay, which will come up eventually. So let me see if you could plot these things on your computer. That helps. So let me see if we have another type of sequence that we want to run a few terms. Okay, so here would be another. Say I have this sequence here, b to the n. Okay, and sometimes they put these brackets around them. Okay, so this is a different sequence than this one. Okay, and I'm gonna kick it out here so it looks like this. So it's 1/2 to the nth power. Okay, so what would this guy look like? Well, when n is 1, you simply put in the value for that. So you'd have 1/2 to the 1 power, and that would give you plus 1/2. So there you go. There's your b at, so this is going to be called your b at 1. Okay, so now if you wanted to do n at 2, okay, then you would get 1/2 to the 2, right, to the second power, and that would give you plus 1/4, and that would be your element or your term b at 2. Okay, and I can go on and go on, and I would get all these elements, but as I went on from 1, n is 1, right, n is 2, okay, dot, 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 I would get n is n at the end. And then in which case I would have b to the n equals 1/2 of the n. Okay, so this would be the general term, nth term, and this is also called the general term and the nth term. Okay, and this formula is the general formula. Okay, so there you go. You got a way of putting a couple of these, and some of these can get pretty crazy. I mean, you know, they're like functions in a way. They could be take on any form. I'll write down another one here and see if we can get into it. So here's a more complicated one. Okay, so if I have b to the n equals a minus 1 to the n plus 1, okay, over 2 over n. Okay, so all right, what would happen here? Okay, and what would this thing look like? So here's an example. Okay, and here's another example. Okay, of a sequence. Now, let me just digress for a moment. So in this case, when I had these answers, if I had 1/2, 1/4, 1/8, that would be determined a sequence. Okay, that's a sequence. And now if I had 1/2 plus 1/4 plus 1/8, and that would be called a series. Okay, so when you start adding them together, all right? So let's look at this guy. So when n is 1, we have to put it into the formula. You have -1 to the 1 plus 1 times 2 over 1. Well, what do I got here? I have -1 to the 2 over 2 times 2. Okay, so that equals really 1. Positive 1 times 2 is just 2. Okay, so that would give me 2. And I challenge you to continue with the other ones, and what you would find out is, so this is b at 1, you would find b at 2 equals -1, b at 3 equals 2/3, and you would keep going, and you're seeing here, I have b at 1 is positive 2, b at 2 is -1, and b at 3 is positive 2/3, and b at 4 I would get -1/2. Okay, so what's going on here is I'm alternating between positive, the next successive term is negative, then positive, then negative. Okay, so I'm alternating here between plus and minus, all right? And I'm going to say that has to do with this guy over here. This has something to do with it. It's a way to alternate is you put a -1 sign into the series or into the sequence, and you raise it to some power. And whenever you get odd powers, you're going to get what? You're going to get negatives. But in this case, with the n plus 1, if it was just n, it would give you odd powers, would give you negative, okay? But now when you're adding one more to it, even an odd n will give you an even n. And then so this is turning it to be even powers are going to give you what? The even powers are going to give you an odd of n, rather, going to give you an odd and going to give you an odd negative number. So that's a little convention in there we see quite often to alternate. So this graph would look quite interesting. You would start out up here and you would come down here, and then you would go back and forth. You're just going back and forth as we go, and it looks like it's going to converge onto the n axis here. So this is your b at n. Okay, and so that's your first point, second, and so on. Okay, so it's really interesting, and all of these sequences or series are interesting, but it's I want to close on one more thing to say, and that I would say that all of this can be related to most anything, but most importantly, I think this data that comes out of these things, we're analyzing the data you find and trying to put these sequences or series, apply them to the data you come up with. That would be the scientific method, okay? And so that would be induction, opposed to deduction. Induction, okay? Induction is when you're seeing patterns and you're making you're predicting the future or something with these patterns, okay? That's induction. And when deduction would be more like the rules of mathematics, okay? Which is interesting. We're doing math here, but the rules of math tell you, all the things you can do. When you could multiply A, B, C, and then you could switch the order, the associative property and all that. So those are giving you all the rules. So that's deduction. So, but the scientific method's induction. So you're looking for patterns, and then when you find the patterns, you can predict the future. Okay, so this is more or less based on that. Well, that concludes this video. I hope you enjoyed it. Catch you soon.